approved. Huh? All right. So good evening, all of you. What we are going to do today is we are going to discuss only the exam related analytical questions, right? Not the theoretical questions, because theoretical questions you can prepare yourself. And again, another advantage of analytical question is if with a similar situation, n number of questions can be framed. So you can answer all of those n number of questions if you understand one question that we are talking, right? So I am of the complete assumption that you all have the sigma level calculator as well as the Minitab access, right, with you. With that, we are getting into the questions one by one. So first question, a lot of steps also explained here on my slide itself. You all can read your question and then try to, find out the answer. I am also there to help you. What is the area contained within -1 and +2 standard deviation of a normal curve? One method is approximately also you can do, because we know some approximate probability, isn't it? Plus or minus 1, the probability is 68.27. That is written here. -1 to +1, 68.27. And -2 to +2, we know that is 95.45. But now the question is -1 to +2. -1 to +1, how much?
68.27.
Very good, 68.27. And now this hatched area, shaded area, has to be added.
Half of that.
Half of what? Half of 95.45 minus 68.27.
27, yeah.
Half of 95.45 minus 68.27. This simple max, if you say you can't understand, then you have a long way to go, right? So unless and until you all speak out, I can't guess whether you are comfortable or you are finding it difficult. All right. So I think this is an easy job. So that's what I did. See here, 68.27. And then I found out the difference between 95.45 and 68.27. That is 27.18. Half of which I have added. So what is the answer? 81.86. Can you see a closer answer here? 81.81.85?
Yes, sir.
I mean 0.8185. That's
Yeah.
it. All of you are with me on this first question?
Yes.
Yes, sir.
How many of you understand? How will you respond then? You all, make us struggle a lot right from day one. Yeah, now one thumbs up is coming and Narmada madam has confirmed. Lakshmi madam, did you understand this question?
Yes, sir.
Yeah. All others, you want to keep the secret within you. All right. Now Sai also understood. Very good. Very good. So I assume everyone has understood. Now one message comes in the chat. So you are making us to work all around. Chat, everywhere. All right. So one option, first question is done. See, this problem can be solved. Do you think this problem can be solved in Minitab? This problem, do you think, if you know this problem can be solved in Minitab, then this question can be tweaked into 100 different questions. Am I correct? I can change this number from -1 to +1. Now, one of you please answer. What is the area contained within +1 and +2 standard deviation of a normal curve? Now, who is going to answer me this question?
+1 and +2 is half of 68.27, sir.
That we already discussed. So what is the answer? Workings are also available.
68%.
Yeah, so
Sir, it is 68.27 plus 13.4 of that, the other one, sir.
No. See,
It is accurate.
all of you got to understand my question. What is the area contained within +1 and +2 standard deviation of a normal curve? +1 and +2. +1 is here, right?
This one is here.
+2 is here. So what is the area? Shaded area.
so 95.45 divided by 4, sir.
95.45 divided by 2. That will be the area between -2 and +2 standard deviation.
Yeah, so here we are talking about +1 and +2.
+1 and +2 only I am asking.
So that part is the whole area will be 95.45.
Yes.
And between
1 and 2.
no,
Plus
okay,
1 and
just
2.
95.45 minus 68.27.
Right. All of you, see, don't, no.
Can I come, sir?
27.
No, not required. Not at all required. Not at all required. See, all of you, we already explained this question. The shaded area, we already calculated and I have written here. Can you see here?
13.59.
And so 13.59 is the answer. That's all. Which is half of 27.18.
Exactly.
I only asked the question in a slightly different manner and then, you started struggling again. No, I don't want you to get confused unnecessarily. If I ask you, what will be the area between -1 and -2 standard deviation of a normal curve?
Right.
What will be the area contained within -1 and -2 standard deviation of a normal curve? Do you understand my question? -1 is here, -2 will be here. Given this scenario,
Same
what
area.
same area, that's all. This is what I want you
Same
to
area.
understand. All of you are with me? I could only understand now. Narmada madam has understood. How about others?
Yes, sir.
Yes, sir.
Very good, right? So,
-1, -2.
to face, and you can't simply know by God all of this. You have to understand. You can't memorize and then you can't do everything with the memory. You have to understand, or otherwise you have to have some assistant with you.
Hello.
Now, one of the assistant is
Okay.
Can you see Minitab here? Now, graph, probability distribution plot, view probability. Okay. In the question asked, do you see that is a completely a theoretical question? Am I right? No situation is explained.
Yes. Yeah.
No situation is explained. That's the time you all must use standard normal distribution. That's the time you all must use standard normal distribution. Otherwise, normal distribution. So standard distribution is nothing but the theoretical distribution. So normal, mean equal to 0, standard deviation equal to 1. This is standard normal distribution. Shaded area. Now I want the area between 2 points. So I choose the last one, between, middle. Now I want to give the x value. X value, middle. If I give -1 here, +1 here, what do you think the area will be between the points -1 and +1?
68.27.
Very good. That is what you are seeing here also in the graph. Minitab has produced it for you. If you know how to produce this, you can produce the probability or the normal distribution curve with the probability for between any 2 points. Not necessarily -1 and +1. See here again I am doing it probability distribution plot, view probability. Okay. Now you tell me randomly 2 numbers. I'll change. Do you want to change the -1 to any other value? Tell me any other number. 1.75. All right. And +1, I want to make it to 0.879. Do you think you will be able to find out the probability between these 2 points? Yes, with the Minitab. Because human brain can't think beyond a certain level.
Do we require Minitab to attend the exam?
Yeah, come again, sir. Hello, Sendil sir, you are saying something? Hello, are you talking?
Sir, sorry for the interruption. So, do we require mandatory for using Minitab while attending the exam?
Yes, sir. Minitab is required. Either you have it or you have it, in some other laptop also, your laptop or some other laptop, or otherwise you have to rely on the cloud version of Minitab.
Sir,
See, I can't say you don't require Minitab. At the same time, I won't say Minitab is compulsory. It is like your hypothesis only. All right. So if you have all these resources, it is easy for you. All these resources are to help you. Using it or not using it is absolutely our choice. There will be 1 or 2 questions that may require. Otherwise, at that point of time, you need where will you seek help? See, now these kind of numbers, definitely we can't do it manually, but this kind of softwares will do the calculation. It can think better and then give us. And another thing is the accuracy of the result. Isn't it? It gives accurate result, no error. So now if you know this, I am sure you can tackle hundreds of situations like this.
So the
Now,
web
who is going
application,
to-
the web application looks slightly different. Can you just show us how to go about entering the values there? Can I just share my screen?
Yeah, that's what I'm going to do
Permissions.
now. One of you have to share the screen. You have to do it, like what I did right now. Actually, this is how the whole training has to go on. But then a lot of basics required and that has been built and now is the right time. Yeah, madam, you can share. I think RK sir, you can enable screen sharing.
Yeah, you can, anybody can share.
Yeah. Yes, madam, please share the screen. So today we will
So
be
this is
discussing
the
only
web,
the, very good. This is your Minitab screen. Very good. Choose the last option.
Sir,
normal
I have a
distribution,
I
mean,
have a
standard
doubt actually.
deviation.
Which menu is this actually?
That's what
Graph.
graph. Through the graph, you have to do it.
Probability distribution plot.
Maybe, madam, you can do
View
it from the first.
probability. Okay.
No,
Graph.
probability distribution plot. Graph probability distribution plot. So click that. And now view
distribution of
probability.
probability, sir.
Yes, okay. Now you have to choose standard normal. That is correct. Options are correct. Normal 0, 1. Now go to option. View the specified x value. Select specified x value. And then you have to choose between middle. The last option. That means you can now give 2 points. Now what is your x1? You give -1 plus 1. You know the answer. Or you give -2 plus 2. You know the answer.
I'll give -1.
You have given -1 plus 2. Very good. Now you give okay. Now Narmada madam is ready to tackle all 100 situations. Now I can set a question asking for the probability between any 2 points. If you know this, now you can solve any problem in real life. Now what is the probability, madam?
0.8186, sir.
Very good, madam. Madam, now I am going to give a real situation now for you.
Okay.
Imagine your company is producing product and the average diameter of your product is 80 millimeter.
Okay.
Average diameter is 80 millimeter and the standard deviation is 2 millimeter. Average diameter is 80 millimeter and the standard deviation of the diameter is 2 millimeter.
Okay.
Now you are producing several thousand units. Now I want you to tell me what percentage of the products will fall under, fall between 79 mm and 81.5 mm. All of you, do you understand? I now created a real scenario because now you understood how to calculate the probability. Now, based on this, what percentage of the products will fall between the diameters 79 mm and then what is the value I said?
81.5 mm.
So this problem madam is going to solve now. Do you think, all of you, do you think madam can solve this now? Yes, madam, please. Graph, probability distribution plot, view probability. Okay.
Okay.
Now for real problem, mean
is
is
80.
80. Standard deviation is
2.
2.
2. Options.
View
Middle.
probability between 2 values. And now what are the 2 values I told you?
79 and 81.5.
Very good. 79 and 81.5. So if madam's company produces 10,000 pieces, certain percentage will definitely be in this range. That percentage we are going to see now. Give okay. So practically, if we know the average and standard deviation, we can understand many things. Now,
0.4648, sir.
that means 46.48% of the products that are getting produced will certainly have diameter in this range, 79 mm and 81.5 mm. If you produce 100, approximately 46 or 47 pieces will fall in this interval. All of you are able to understand? All
Yes,
of
sir.
you, are you able to understand? Very, very important learning. Ultimately, as a Six Sigma expert, this is actually a basic thing only. But then, with the help of softwares like Minitab, you will feel completely empowered. You can handle any scenario. You can handle any scenario. I told there are companies producing some products. Let's say your company is, processing a customer order. Processing a customer order, and it takes 80 minutes to process the order on an average. For the same scenario, according to the available data, the standard deviation of the processing time is 2 minutes. Will you be able to judge now the possibilities of processing the order between any 2 point of time? I mean, between any interval of time. You should be able to calculate, isn't it?
Yes.
So, if you can take care of your average as well as take care of your standard deviation, it is as good as taking care of our future performance. What percentage you want to see between two important points? If that important points contains the maximum proportion and the points are well within the customer requirement, you are running a very, very capable process. That's all. Hope all of you understand, right? Thank you, madam. You can stop sharing right now. All of you can practice like this parallelly. Shall I give you 30 seconds for that?
Yes, sir.
Okay, you all can do it yourself.
1 second, sir.
seconds. But if you again show a lot of resistance and you don't want to come in line, then our job will be difficult, right?
Sir, 1 second.
Now you started sharing, yeah? Okay, you can teach others, madam, then. Now who is sharing?
No, I'm sharing my screen,
Yeah,
sir.
you can teach our participants for 30
Yeah,
seconds.
but I want to change this number. I have given the reference.
Yeah, go again, go to graph. Go to graph.
Graph.
Go to probability distribution plot.
Yeah.
Come down, come down. You have chosen something different. Cancel. Graph. Probability distribution plot. View probability.
Probability, okay. Compare to distribution.
No. You first learn one by one. View probability. Now you give your data. Mean and standard deviation. Standard deviation, you are given too much, too high. That cannot be. Maybe 2. 2 is our discussion. But according to the real-time scenario, you can choose. And now
Means,
go to option. Mean is okay. Go to option. And now choose the numbers. Give the numbers. Now choose the X value in the just in the top. Specified X value. Now you can give the X value. Again, choose the middle. Yes, it is corrected. It is correct only. Now you can choose 2 value. What is the chance for completing the work between 70 minutes and 90 minutes? What is the probability for completing the work between 70 minutes and 90 minutes? Oh, 70 to 80, yeah, okay. You give okay. Now there is how much chance? You can see. Just bring it down. Very good. You can right side, there is a vertical bar. No, you can just put, right. There is 50% chance for you to complete the work between 70 minutes and 80 minutes. I can ask different questions. What is the chance for you to complete the work within 60 minutes? Do you get my question now? What is the chance? Your average itself is 80 minutes. Standard deviation is 2 minutes. I am still asking you, what is the chance for you?
சார் ஒரு சின்ன டவுட் சார் கேக்குதா
கேக்குது சொல்லுங்க சார்.
சார்
எஸ் எஸ் யூ கேன் ஸ்பீக்.
கேக்குது ஒரு சின்ன டவுட் சார், சங்கர் பேசுறேன். இப்போ நம்ம லேப்டாப்ல கீபேட் இருக்குல்ல,
ஆர்கே சார் ப்ளீஸ் மியூட் ஹிம்.
அது எந்த ஏபிசிடி எதை அமுக்குனாலும்
One second.
ஹலோ சங்கர்
கீழ
சார்
உள்ள அந்த ஃபைல் விண்டோஸ் இதுதான் ஓபன் ஆகுது. ஏபிசிடி லெட்டர் டைப் ஆக மாட்டேங்குது.
This is what I
இது
told
ஏதாவது
you.
key
Our people
அமுக்கிட்டேனா?
are now over smart. They attend 3-4 training programs in parallel and finally end up mastering
கேக்குது சொல்லுங்க.
nothing. Okay sir, can you mute him?
ஆமா ஆமா ஆமா.
Or you give me the it's bad. Sir, you send him to waiting room. Yeah, that's good.
Sir, I think there were 2 questions, sir, from this actually in the mock.
Yes. Yes, Sai, you want to ask something? Am I audible?
Yes, sir.
Sai, but you're
No,
not.
yeah, Bharat this side, sir. I think my computer name is Sai. So, yeah, there were 2 questions around this, sir, in the mock test paper. Thanks for giving this, sir. Thanks for giving this detail. Yeah.
All right. Anyway, you are now good, right? Okay. Now we proceed. And this is a theoretical question. You all can, just read yourself. I want to go with the practical question. See here, a random variable, maybe the exam mark of the students, or maybe the diameter of the product, or maybe the time to process a particular order, whatever it is. It's a random variable. Average is 80, standard deviation is 2. X is the mark scored by the student in the mock test. What is the probability that his score will be between 75 and 85? All of you, do you think you can solve this problem?
Yes, sir.
Yes, sir.
Certainly, right? Any scenario hereafter in your
75.
meeting discussion, if somebody is talking about a scenario, just ask them 2 things. Hello, do you have the average value? Do you have the data? If you ask the data, standard deviation also can be calculated because they can't understand if you ask for the standard deviation. So get these 2 values. Now the horoscope is in your hand. Between any 2 interval, what can happen? You can actually understand and then you can make changes accordingly or discuss accordingly. So this question also can be answered. No issues here. You all can do it yourself now. Can you tell me the answer here?
98.76, sir. 0.9876.
Beautiful. 0.9876. See here, answers are very close, but still he could figure out the right answer, isn't it? That's the advantage. Now, next question. Find the quartile Q3 in the distribution where average is 80, standard deviation is 2. What is quartile 3? Do you know the meaning of it? Quartile 3 means, what is the meaning? A point below which you will have 75% of the area. Above which you will have 25% of the area, isn't it? So choose one tile, maybe left tile. Left tile means below. What should be the area? 0.75.
25%.
So what will I do is, I will show it, then you all can do it yourself also. So I am taking you to Minitab. Same scenario only we are talking. Graph, the probability distribution plot, view probability, okay. And now it's a real-time scenario. So I'll give the mean value. I'll give the standard deviation value, shaded area. Now Q3, we are talking about Q3, isn't it?
Yes,
Q3 means
point. More than the point below 75%.
Below 75, above 25.
Above
so
20.
Let us choose the left tile. That means below area we have to declare. I know only the probability, but not the X value. So I click the probability. I choose left tile. What will be the probability below that point? 0.75. Now the point value I want to know. That point is known as Q3. I give okay. All of you, can you see Q3 value here? 81.35. If I ask you Q1, then below area should be 0.25. If I ask you Q2, then the below area should be
50%,
0.5.
0.5.
That's all. So now
Okay.
you all can find out what is the Q2 here or Q3 here. Just now we solved, right?
0.75.
No. In this problem, Q3,
81.35.
C is the correct answer. You all can do it in your laptop also. 30 seconds for you.
So specified probability, right, sir, in the option?
Yeah,
Not
I
the
specified
specified
probability.
X value.
For Q3, the probability for the points to come below Q3 is 75%. So I gave probability and got the Q3 value. You can also do it yourself parallelly. So 30 seconds.
81.35. Yeah, C.
It's coming. That's all.
81.35
That's
was
all.
the-
So I can ask you several questions, right? What will be the Q1? If I ask you what will be the Q1, then below area will be 0.25. Isn't it? So I can ask you what is the difference between Q3 and Q1? That is interquartile range. So you find out Q3, find out Q1, and then find out the difference. That is interquartile range, right? So there are several questions possible. Now, this is a theoretical question, but still I want to ask you. According to central limit theorem, regardless of the nature of the population from which the data is drawn, the sampling distribution, which means distribution of sample averages, that is known as sampling distribution of the mean, will be normally distributed. Do you think the statement is always correct? Or do you think the statement is always incorrect? Or do you think the statement is correct subjected to certain condition? Or do you think nothing is applicable or nothing is relevant?
That's always correct, sir.
Always correct.
Always correct only.
Do you remember our discussion about central limit theorem?
Okay,
Then what is
the,
our understanding?
okay, the sample size and quality of sample should be known.
Subgroup average always follow normal distribution. Only two things important: sample size and sample quality. I told you. So conditionally correct, isn't it? If that conditions are met, yes, you will see your data following normality. Very good. I should appreciate Bharat Kumar. Now, next question. An extrusion die is used to produce aluminum rods. The diameter of the rods is critical to quality characteristics. The specifications are 100 plus or minus 0.5. What do you understand here? Upper specification is 100.5. Lower specification is 99.5. The process average is 100.31. And the estimated standard deviation is 0.05. And you have to calculate or compute CP. Please note down all these values. You have to tell me. Please note down this value. USL, LSL, process average 100.31, standard deviation 0.05. How can I solve this? Like, you can solve it manually. You all have learned the formula. We taught you the theoretical way also. But real life, we need faster answers, right? So can you see the sigma level calculator file opened by me?
Yes,
Now
sir.
go to CPCPK sheet. Here you just have to type your values. What is your upper spec limit?
100.5.
Lower spec limit 99.5. Now what is the average that was given?
100.31.
100.31. What is the standard deviation that is given?
0.05.
0.05.
Just type these values and give enter. Now what is your CP coming?
1.83.
0.8385.
3.33, not 1.83. 3.33 is coming, CP. CPK is 1.26. What is the question asking? CP value. All of you, are you getting this?
Sir, I'm getting a totally different value here, sir.
Sir, I am also getting
Acha, we have
1.83
taken it
only.
here.
Yeah. Okay,
Are
but
you
actually
using-
3.3 is the.
Wait. Are you using the same sigma level calculator file which I am using right now?
Yes, sir. It's showing the same one. Actually, we have to use the version 6.
Sigma level calculator V6.
Okay.
That is the thing I have shared.
Yeah.
Yes.
Right?
Replicating
So
the
maybe
3.33.
one of you can post it again in the WhatsApp group so that everybody can use Sigma
Yeah.
level calculator V6. Manual method also will give the same value only, 3.33. But don't use any template, which is giving a wrong answer, right? So it should give 3.331. Clear, all of you?
Yes, sir.
We move on. All right. Now, so see here, 3.33 is one of the option. You can use it. Now, desktops are being inspected. Whether the following components are functional: RAM, motherboard, screen, hard disk, Bluetooth, memory slot. How many checkpoints? 6. This is what we studied as opportunities or defect opportunities, right? Number of opportunities are 6. 1,000 laptops are inspected, and in the end, 238 defects are observed. After inspecting 1,000 laptops, 238 defects observed. Now you need to find out what is ZST. What is ZST? So again, how can we solve this?
Sigma
We
level
should
calculator.
go to the sigma level calculator. Now this time, sigma level calculator, I'm clicking. I don't think this will be helpful. I go to this discrete data situation. I think this will be helpful for me. How many is the OFE? Opportunities for error or opportunities for defect? 6. Can you see?
6.
I am changing it to 6. Now, how many desktops are inspected? 1,000.
1,000. So sample
How
is
many
1,000.
defects are noticed? 238.
238.
When I enter, this template is giving me DPMO, ZLT, ZST. Depending on the question. See, I can change the number. I can ask for DPMO, ask for ZLT, ask for ZST, anything. But now this time the question is ZST. So what is the answer?
3.25.
4.86.
3.25. So let me check whether that option is available. Can you see 3.25 here?
Yes, sir. First
Yes.
option.
So that is the correct answer. If you do it parallelly at least once, then only you will gain the confidence. Right? So everything, the confidence cannot go simply, if you observe. But if you also try once, then it becomes, very simple task. Now, another situation. I think now I don't have to explain. You all should be able to do it. And tell me, will you be able to solve this scenario? Read and then tell me. Or do you still require someone to handhold you? Will you be able to solve?
Yes.
If you can solve, please open your sigma level calculator. Because sigma level calculator also solves this. Minitab also solves this. And manually also you can solve. Your brain also can solve this. But now, which is significantly better? Your brain or sigma level calculator or Minitab? Which is significantly better? You can
Sigma
use
level
that.
calculator.
Yes, please go for it. So definitely we can solve, our brain can solve, but then it might take time and it can be less accurate also sometimes. Please try and then tell me. Now you need to understand certain things here. Some challenges are definitely here. Dimension of the part should be between 125 and 130. What is this information?
Up USL and LSL.
LSL is 125, USL is 130. Operator collected a sample of 100 parts and average is 126. What is this 0.25?
That's variance. So we need
Variance.
standard deviation. We need to just variance.
Very good. We require standard deviation in our calculation. So convert the variance into standard deviation. For that, you have to take the square root.
0.5.
But you have to be careful. Maybe. Is it 0.5?
Yes, sir.
Yes, very good then. So now you have the standard deviation, average, USL, LSL. You need to find out ZLT and ZST. So anybody got the answer? Anybody got the
Option
answer?
C, sir. 2 and 3.5. 2.0 and 3.5.
So one of you who feel comfortable, you can now share your screen and explain to others. Please do it. All of you can participate, not necessarily the same person to do everything.
So this continuous process has this information that we need to enter. The
Very
USL
good.
is 125. Sorry, the LSL is 125. The USL is 130. Mean is given as 126. Standard deviation is calculated as square root of variance, which is 0.5. We
Very
entered
good.
all the values and we got DPMO to be 22,750.
Correct. Now, the main thing
2.0 and sigma short term is 3.5.
very good. You got the answer. Madam, also please can you explain how to convert the variance to standard deviation in a separate cell somewhere? Because Excel has the square root function, right? You
Yeah.
type the variance somewhere as 0.25.
Is equal
Square root of SQRT of 0.25. SQRT.
internet connection is
SQRT
internet
of.
connection is unstable, sir. 0.25.
That's all. And then you can close the bracket and enter.
0.25.
Now you got the standard deviation. Hope all of you are very, very clear now, right? Whatever be the variance, that is converted into standard deviation because standard deviation is required in the formula. And so we are converting and using. Thank you, madam. You can stop sharing. See, analytical questions are the easiest because you solve it in 10-20 seconds if you are equipped properly. All right. So we continue. We are here now. A KPO processes reimbursement receipts for the customer. The time to process a refund claim is 30 minutes. And the customer expects the invoice to be processed between 25 minutes and 35 minutes. This is only an assumption, right? Normally, customer wants everything below. They don't give a range. But anyway, no problem. So it's an exam sake question. So the customer specification is between 25 and 35. And now what is the ZST value? And see here, data is given in the problem itself. That means instead of giving you the summary, the raw data is given. In the same sigma level calculator file, a sheet with the name refund is available. You can use that sheet. Otherwise, in the exam itself, the data, no, you can open the data. And then you can copy and then put it in the Minitab. So right now, I will show you this particular problem. We need to find out the mean and standard deviation from the data. And then use the USL, LSL. And finally, we need ZST. So what can we do? Let me go to the sigma level calculator file. Where is it? It is here. And now I just look for the refund. I should get it. Am I getting it? Yeah. Can you see refund here, all of you? All of you can see
Yes,
refund,
sir.
right? Yeah.
Yes, sir.
Now for this data, I just need the average, nothing else. If the average is given directly in the question, all good. Otherwise, I just do it myself. Now the average is note down, please note down the average 22.09. Another thing I want is standard deviation of the sample, stdv.s. And from here till this. Now the standard deviation is 5.96. Please note this also. Please use these two values and your USL, LSL is how much? USL, LSL. And they have told us no, customer expects something between 25 and 35. That is USL, LSL. All of you are with me now?
Yes.
Please do use your X sigma level calculator and let me know. You can find out the ZST, right? That is the question, right? Now I will show the question. You are going to tell me the answer. And yes, you have to find out the ZST. Which is the best answer here or the right answer?
0.97, sir.
Very good, 0.97. All of you are getting the same answer?
Yes.
One more person, can you confirm? Second opinion. Is that 0.97 correct? Checking for one more person. Are you getting up? But that means the second person is not doing, only one person is doing everything, always.
No, sir, it's difficult to navigate between the two screens, the two sheets. That is the problem.
Yeah, that is that also. You have to equip you, all of you. Or you all can, keep one more device. Don't try to do. A laptop is must, first of all, right? I don't think you can manage, you can do all of this in a phone. That's definitely impossible. So all of you are getting this answer? I don't know. I'm not gaining confidence with all of you right now. Are you?
1 second, sir. Just please give me 1 second. I need to copy the values. The formula isn't getting copied.
Okay.
Copy.
You can keep your Minitab opened, sigma level calculator also opened. We are going to use only these two. And another thing, all of you note, in the exam also, 75 minutes, sorry, 2 hours, right? 2 hours, 75 questions. So you have to move from one question to other question at least in 1.5 minutes. You can't say, extra time is required. That's not possible.
Yes, sir. Sigma level short term is 0.97.
Very good. Thanks for the confirmation. Now there is a second opinion. There is repeatability. So we proceed. 0.97. Now next question, and this is
Isn't it reproducibility, sir? Isn't it reproducibility? Different people checking the same thing.
Okay, I will call it reproducibility because two different appraisers. Very good. Correct. So same measurement system is repeatability. Different measurement system, reproducibility. So different appraisers, reproducibility.
Oh.
Great. So laptops, similar situation. Laptops are being inspected to check whether the following components are functional. RAM, motherboard, screen, hard disk, Bluetooth, memory slot. Again 6. But this time 500 laptops are inspected, but there are only 190 defects. I think you will do it. You all will do it, right? Go to the Excel calculator and then put it and you should get the answer. Maybe you can try with the numbers. Anyone able to complete fast?
3.25, sir.
Very good. Because it's the same situation, almost 3.25. Now we are moving on to next question. In a MSA study, measurement system analysis, gauge R&R is 0.59, total variation is 0.6. Find the part-to-part variation. All of you hope we all know one thing, the relationship. Total variation is equal to part-to-part variation plus measurement system variation. Am I right?
Yes, sir.
Variation, there are two sources. One is the process itself. That is what we call it as part-to-part. Another thing is variation can come from measurement system.
Measurement system.
Gauge R&R. Now total variation is 0.6. Now tell me.
0.622 minus 0.590.
Yeah,
Answer is C,
0.032.
0.032.
Yeah.
Very good. Beautiful. Very simple. Total variation equal to gauge R&R plus part-to-part variation. This is the equation you must use to find out the part-to-part variation. Very good. Now a black belt is developing a failure mode and effect analysis. And in a particular scenario, severity is 3, occurrence is 2, detection is 9. What will be the RPN?
45.
54. 54. Six nines are 54. 3 into 2 into 9.
No, 45.
3 detection 9.
3 into
3 into
6.
2 into 9. 6 into 9.
40, 54. Yeah, 54.
54.
Very good.
S
Just
into
multiply.
O into D. Yeah.
Multiply the 3 numbers and then you get 54. Very good. Find the sample size for a one sample Z test given the following. The difference in the mean is 0.5. The population standard deviation is 0.75. The power of the test is 0.95. Confidence level is 0.95. Now see, always better you understand the situation, you can work more accurately. You can judge the correct sample size if these informations are available with you. You should know when you are working with the data, you should know what kind of hypothesis testing you are doing. So what is this test actually? One sample test.
Z test.
Certain conditions are known. Only unknown is sample size. Let me tell you now how you can get the sample size. And this requires some probability calculation. That's why I'm taking you to Minitab. So I come here. There is a stat option. Can you see sample size, power, and sample size? Stat option, power, and sample size. Now come to the right side. Choose one sample G test because you know the situation is one sample G test. Choose this. Now sample size, we don't know. Leave it. Difference means difference in the average. How much is the difference in the average? 0.5. Let's say you are studying two types of process. One process is giving a compressive strength of 120.2 Newton per mm square. Another process is giving you a compressive strength of 120.7 Newton per mm square. What is the difference? 0.5. Now you have to prove the difference or the increase in the compressive strength is because of the new process. That is the hypothesis testing you are doing. So 0.5 is the difference in the average. Power, how much power you want in your hypothesis testing? 0.95. Standard deviation means known standard deviation. That is 0.75. This is given, isn't it? Now option. You want to keep it as a two-tailed, one-tailed, or let it be two-tailed because it was not clearly specified. So two-tailed, not equal to. Significance level 0.05. If significance level is 0.05, confidence level is 0.95. Am I right?
Yes, sir.
With this information, I give okay. If you give all this value, the unknown value will automatically come because these are interconnected. So I give okay. And now can you see a curve called power curve? What is this Minitab now telling me? How many samples are required to prove a difference of 0.5 as a significant difference because of the new process? In order to validate your claim, minimum sample size required is 30. All of you are with me?
Yes,
Only when you use 30 samples and the average and standard deviation, and with all of this, p-value will go below 0.05. This is what we have taught you. Please check p-value going below 0.05 or not. P-value will go below 0.05 only under this condition. And that condition also takes into account sample size.
Sample size.
Why? You know why too many samples are required? The difference is very, very small. If the difference is marginal, you may have to take more sample to defend it. If the difference is high, sample will come down. Shall we test that? Stat, power and sample size, one sample Z. What happened? Stat, power and sample size, one sample Z. Now I am going to make this difference as 0.5 to 0.8. Now what should happen to the sample size? It should increase or decrease? Come on. Sample size. Oh, sorry, I switched off my video. Sample size should increase or decrease?
It should increase because the difference is increasing.
Difference is increased. So what should happen to the sample size? If the difference is large, it should decrease. You don't require more sample if the difference is more. It is quite obvious. So with less sample, you can climb. See here, what happened to the sample size?
Oh, wow, 12.
So what is the relationship between the sample size and the difference in the statistics? Inversely proportional. More the difference, lesser the sample size. Lesser the difference, more will be the sample size. See, these kind of tools will make you feel more comfortable. Am I correct or not? You can handle and then take decision in no time. So we proceed now. This is done. Here it's a question is too lengthy, but I'll make it simple for you. There is a hospital where there are 4 laboratories and you are the chief in the hospital. You doubt whether all the laboratories follow the same procedure, whether all the laboratory finish off the process consuming the same amount of time, because time is a major concern. You all agree with me, isn't it? So now you as a chief, you have a doubt whether any particular laboratory is taking more time to complete a particular diagnosis, which is frequently happening in the hospital. That time required to complete a diagnosis, that is, considered as, called as turnaround time here. Now the turnaround time data is collected for all 4 laboratories and that is available. You all can see the information in our Excel file. Now, what is the question now? Whether the average turnaround time is significantly higher or significantly lower in any one of the laboratory. That is your clarity needed. Now tell me which hypothesis testing it is.
It's null hypothesis testing, sir. Reject.
Null hypothesis is a statement.
Correct.
What is this hypothesis testing called now? As a chief of the
ANOVA.
hospital,
ANOVA.
As a chief of the hospital, you want to know whether a difference exists among the 4 laboratories within your hospital in terms of turnaround time, which is a continuous data, measurable characteristics. So the average turnaround time has to be equal. That is your requirement. That is your expectation. That is your belief. Whether that belief is correct or not, whether the null is true or not. Will you end up rejecting your null, or will you end up accepting your not rejecting your null? If you end up rejecting your null, it simply means one of the laboratory is significantly performing in a different manner. There is a significant difference in one of the lab. For that, you have to work with the data only. I already told you data. Where is the data available? If at all in the any data required, it will be given in the exam itself. If you have a problem over there, that's where all these data I have given as a backup here, right? If you have any issue there, you can pick up from here also. Nothing wrong. So much data available. Now take the turnaround time. Lab TAT should be available. Yeah. Can you see lab TAT, all of you? Now,
Yes.
in order to do the ANOVA, you just have to copy all this data. ANOVA template, RK can give you if you want to do it in Excel. RK sir has developed beautiful templates, but you should know how to use them. Otherwise, you can't use. Now I am coming to Minitab. I place my cursor in the gray bar, paste it here. Now data is available in Minitab. I will say there is a significant difference if the p-value goes below 0.05. Am I right? So stat, ANOVA, one-way ANOVA, and then data in separate column. And these are the column 1, 2, 3, 4. Select option. Always we assume equal variance, 90% confidence level, two-sided. Okay. And again, okay. All that you need to check is whether p-value is less than 0.05 or more than 0.05. Can you see the performance of all the 4 laboratories in the diagram itself, all of you? What is this center point blue color dot? Average turnaround time. Am I right? What are these lines?
Yes.
There is a line here, there is line here. What is this line?
UCL and LCL.
This is not UCL. This is up 95% upper confidence limit, 95% lower confidence limit. I have taught you, remember Virat Kohli's batting average and he scores between 50 to 60. That should not be called as control limit. That should be called as confidence limit. Here it is 95% confidence limit. Of course, in short form, that is also UCL. But it should be called as upper confidence limit, not as control limit. All right. Can you see any confidence interval of any particular laboratory completely away from the confidence interval of other laboratories? Can you
Yes.
see 3 completely away from, completely above all the 3? Can you see 4 completely below all the 3? But 1 and 2, there is no difference. Here, you can't reject your null between 1 and 2, which is a 2-sample t-test. But as a whole, 4 as a group together, you see 2 observations. 4 is significantly lower and 3 is significantly higher. Laboratory 3 is taking significantly more time. Laboratory 4 is taking significantly less time. I could see a significance here. That means the p-value should be below 0.05. Can you see here p-value? P-value below 0.05. That means you reject the null. That means there is significance. There is as
Sir,
a
once again, can you show the options? Are we going to start ANOVA? Which options, sir? One-way ANOVA?
stat ANOVA, one-way ANOVA only.
Okay.
One-way ANOVA only. And then we choose this option, data in separate column, because we put the data in 4 columns. And then these 4 columns are nothing but C1, C2, C3, C4. Either you can choose them one by one or select them together. 1, 2, 3, and then 4. And then always for ANOVA, the condition is equal variance. So I choose equal variance, okay, and one more okay. The test is done. And when I go to session window, I get the p-value. Either you look at the p-value or look at your confidence limits and see whether the confidence limits are significantly away. Or are there any overlapping? If there is a overlapping, then we don't take any decision. But if it is completely outside, now we gain the significance. And now we will confidently declare, yes, laboratory 3 consumes significantly higher TAT. But laboratory 4 consumes significantly lower TAT. As a chief of the hospital, you can now make a decision. Isn't it? You can even take action on laboratory 3. Why are you taking too much time? You are making patients to wait unnecessarily. I have a solid evidence. Look at 4. The laboratory 4, their average TAT is only this much. So you can take decisions in this manner. So now moving on. For a particular hypothesis testing, alpha equal to 0.05 and beta equal to 0.10. The power of the test is, can you tell me how much is the power now? Beta equal to 0.1. Beta equal to 0.1. How
90,
much is
sir. 0.90.
So beta and power, there is a relationship, right? When beta is 10%, power is 90% or 0.9. So we move on to next question. Next question. Find the significance level when the characteristics value is not allowed in the extreme and beyond 1.5 standard deviation. How many of you are able to understand the question? Find the significance level when the characteristics can be anything. It can be diameter, it can be processing time, it can be turnaround time, or it can be the current flow, or it can be, your signal strength, whatever. Depending on your domain, you use characteristics. That characteristics is not allowed to move 1.5 standard deviation from the target. If it goes 1.5 away, more than 1.5 standard deviation, then your organization finds it significant. That means it expects you to take an action. Now you are asked to find out what is this level of significance. That means the alpha value they are asking. Do you find some way to answer this question?
Yeah, sir. Actually, one standard deviation, both sides is 68.27. So that means if it is actually 1.5, that means it's gone to the second standard deviation. So that is 86 is the answer.
Not
No,
86.
it's beyond.
Not 86.
It is beyond half.
Outside the 86.
Half.
Within,
Okay.
Very good. Within 86, your management is absolutely okay with you. But if it goes outside, that's where your management expect you to take an action. I'll show you how you can do it. Go to graph, probability distribution plot, view probability. Okay. But now real-time scenario is not given. Whenever real-time scenario is not given, what you should do? 0. Here 1. Shaded area. Between or outside? Outside is significant. Between is
Acceptable.
no the preferred area. So I choose outside. And both side 1.5. Am I right?
Yes, sir. It's
Both side
minus-
one.
X value is minus 1.5 here. Yeah.
I can
So
say 1.5. That means minus 1.5 on the left side, plus 1.5 on the right side. That's how it should be taken.
Okay.
Now I give okay. Now how much it is coming? 0.066.
0.6.
This side 0.066. What is the area of your red zone, which is significant zone?
0.5.
Right side.
6.6% right side, 6.6% left side. Totally,
Uh,
13.2% or 13.3%. Am I right?
13.
Are you able to see 13.36 here?
13.36. Yeah, first
That is
option.
the answer. That is the answer. You have to sum up both values. Right side also extreme is significant. Left side also extreme is significant. That's why that is indicated in red. Now moving on to correlation analysis. If the correlation coefficient is 0.9, the percentage of variation in the response variable explained by the variation in the explanatory variable. Explanatory variable is X variable. Response variable is Y variable. And the correlation coefficient small r is 0.9. How much percentage of the variation in Y, delta Y, is explained by delta X? That is the question.
B, 90%.
D, R square is the
100%.
answer. 0.9 multiplied by 0.9, 81% is the correct answer. Am I right? 81% of the variation
Sorry,
in
sir?
Y is explained by the variation in the X. Answer is R square because R is 0.9. So R square is 0.9 into
Oh, R is 0.9. Okay.
R is 0.9. So R square is 0.9 into 0.9, 81%. This is what we discussed.
81%.
The coefficient of correlation between these two variables, U and V, but they are related like this: U equal to X and V equal to minus X, which means U equal to minus V. Am I right? This means U
Yes,
equal
sir.
to minus V, isn't it? So what is the coefficient of correlation? Let me write it here for you.
B, -1.
-1, very good. If you have this equation U equal to minus V or Y equal to minus X, this is your correlation coefficient, which is -1. B is the correct answer. Hope all of you understand, right? Now we move on. Oh, this has to be erased. Now next question. In two-way ANOVA with one factor at 4 level, another factor at 3 level, without replication, the total degree of freedom. Will you be able to find out the degree of freedom? In order to find out the degree of freedom, total degree of freedom, you should know total number of readings or total number of experiments. Can you tell me what will be the total number of experiments?
12, 4 to 3, 12.
12, yes. 4 into 3.
3.
The levels of the first factor multiplied by level of the second factor and so on. Here there are only 2 factors. 4 into 3 is 12. So there is no replication. So total number of experiment is 12. So total degree of freedom is 12 minus 1. 11 is the answer. Now, in one-way ANOVA, right? In one-way ANOVA with 4 levels, of a factor without replication, what is the degree of freedom?
3, n minus 1. 4 minus
Yeah.
1, 3.
All of you are
N
able to
minus 1, yeah.
understand there is only one factor and 4 levels. So 4 experiment. So degree of freedom is 3. Very simple. Now just to test, I am asking another question. Imagine there is a factor with 4 levels. Another factor with 3 levels. There is one more factor with 2 levels. And replication is 2. 4 level, 3 level, 2 level, and replication is 2. Now, what will be the total degree of freedom?
4 levels, 3
Yes,
levels?
One is the answer.
First factor,
No, sir.
4 level. Second factor, 3 level. Third factor, 2 level. 4 into 3 into 2. How much?
6.
24.
24.
4
And
into 3 into 2, 24.
replication is 2. So 24 into 2,
48. 48.
Total
48
experiments,
minus
48.
1.
The total degree of freedom, 48 minus 1, 47. Very simple statistics you are learning here. Please note. If you think, everything is a bouncer for you, it simply means, you are considering everything as a bouncer. It is a, playable ball. The thing is, you should, first of all, understand that we are discussing only simple stats, not deeper stats. And okay, next question. A process excellence team in a bank inspects transaction. There are 7 opportunities for error in each transaction. Opportunity means defects. Opportunity means defects. 100 transactions are inspected every day. That means every day the number of samples are constant. Every day number of sample is constant. And number of errors or number of defects are recorded. Now, which control chart you will use to monitor the process and control the process?
The C chart, sir. C chart.
Okay. Okay. So very good. Maybe you are correct. I think Bharat is perfectly correct. You need to know whether you are monitoring defect or defective. That is the first classification. Are you monitoring defect or are you monitoring defective? Defect. Isn't it? Number of errors means defect only. So once you know you are monitoring defect, there are 2 options, C chart and U chart. The P and NP are meant for defective. And within C and U, when the sample size is constant, you have to go for C chart only. When the sample size is variable, that's the time you will go for U chart. We should appreciate Bharat for giving the right answer, right?
Yeah,
That's
the
the correct answer.
yeah. Yes.
Now let me check whether all of you have understood. An inspection process checked the parts produced for defectives. Now tell me, are they monitoring defects or defectives?
Defectives.
Defectives.
That means answer is between P and NP.
P and NP.
Yeah. Now, in order to understand, you should know the subgroup size. The total number of parts produced shift-wise and the number of defectives recorded were recorded for 24 shifts. Which type of control chart you will use? The number of parts produced
because
every
it's
shift.
variable.
The number of parts produced every shift can be variable. Isn't it? We are not getting same number of participants in every batch. Sometimes it is 35, sometimes it is 45, right? So variable. So which is the best option here?
P chart.
P chart. P chart for variable sample size. NP chart for constant sample size. Which of the following is not included in the list of 7 waste according to Lean?
C. No proactive risk
No,
analysis.
Very good. Which of the following technique dramatically reduces change over time?
SMED, sir. Last option.
Single minute exchange of dice. That is the correct answer. A system that delivers products or services at the correct time and in the correct quantity is referred to as
Just in
sir.
time.
Just in time.
like how all of us are discussing right now. You have got the exam day after tomorrow and we are at the right time we are talking about. That's why we could see, a lot of attention, right? So just in time, the same thing is required. That's it from me. And now you have any specific question to ask? Myself as well as Dr. RK can answer. And we have some time for that. So I stop my recording here.